working on it.
5, 4, 3, 2.
Hello, Adam. We hope that you made it safely to We just did a lab, and it was a very short one. We're not writing it up, but we are doing the calculations. It's one you can easily do at home. So would you look at, can you get that paper in?
Recruiting Crusaders in Florida.
What page is this in your book? Does anyone know? It's not written on there. All right, in the middle of Mod 2 somewhere, this page is, and this will, we are going to demonstrate it for you. So, you would do it one more time for the camera.
Hey.
All right, so I'm going to be the catcher, and you're going to be the releaser. Once you read the lab, you'll see that I have these pinchers at a certain number. Say it's at 2, and he's going to release it. Woo! And so I caught it at 15. So we're going to do that 5 times and average it, and use the equations to find time, reaction time. We ended up going to this one because we had no information about final velocity. All right, that'll become more clear to you, and you can do that with anyone when you come into the possession of a ruler. You might not have packed your ruler for Florida
land.
All right, when you get home, that'll be very quick for you to do, but put it on your list.
It's on page 54.
All right, thank you.
Page 54.
All right, here is the handout for today. Nothing much of interest except that we're throwing upwards. I try to think of another way to say it every year, but I haven't come up with one. Perhaps you can help me. All right, drawing. I need a hand throwing, a tossing. How about tossing upward? That would have been nicer. Draw a ball being tossed upward on your day 4 notes. Draw a ball. All right, the board in, pretty good. All right, then you can just leave it go.
Stop touching it.
Except, I do need that 15-minute mark. So
Okay.
maybe at
I got it.
8:32 or something.
Got
We
it.
already taped for a few minutes, so.
It's broken off.
Oh.
All right, do you have your sketch? I see not a
I
sketch.
can't really draw hands, so it looks like a bush.
Sketch.
It does look like a bush.
All right. So we're tossing the ball straight upwards. Make sure that the arrow goes up. If we slant it, the calculations are massive, which we will, but not today. So the arrow
The
has to
camera's
go
slanted and
straight
her hand was
upwards.
perfectly level.
All right. So Kevin, you up with this?
Yes.
All right.
It's 4
So
fingers.
what happens to the path of this? If that's a velocity arrow, let's say that it has initial velocity of 3.5 meters per second. So mark that on your sketch. And as it goes up, the velocity arrows are going to get shorter because it's going to slow down. And we have to remember why. We know it does from experience, but we need to remember why. Because the velocity is upward, but acceleration due to gravity is downward. So when we have the opposite signs, we learned previously that it is slowing down. So it's slowing down. And at the very peak, what is the velocity?
0.
It is our old friend 0. So we're going to put velocity at the peak is 0 meters per second. And then, in a mystifying way, the whole thing reverses and things starts coming downward faster and faster, accelerating toward the Earth. At any point, as we go up and down, at any point where those two are alike, say right here, right after release, at this point on the way down and this point on the way up, the velocities are the same, except opposite signs. One's going down and one's going up. If there's no air resistance or any other force. So it's going to go up from 3.5, go slower and slower until it zeroes out. Then it'll start speeding up, and when it gets back to where it was at just before release, it'll be back to 3.5 meters per second downward. That same phenomenon takes place anywhere. So let's say we're right here and right here. I don't know what the velocity is on the way up at that point, but it's going to be somewhere between 3.5 and 0. Let's say it's 2.0. If it's 2.0 on the way up at this point, on the way down at the same level, it's also 2.0. So that's interesting phenomenon for throwing upwards. With that, you have all the information that you need to do a problem. So let's say we have, that's just a training sketch, and it gives you the information that you need to follow the 3 kinematic equations to the answer. So let's do a real problem. This time it's a bullet being shot straight upward.
I feel like with our previous problems, this bullet's going to be traveling at like Mach 98.
Yeah.
So here we have a bullet.
Like 900 million
I have a
miles.
little handgun here.
We have a car that can do Mach
We have
14.
Greg's little handgun. And so the bullet is going upwards,
Flare gun.
straight upwards. So I'll give it several velocity vectors, slowing down. Just like tossing the ball upwards. And then it'll turn
Wait, who
around
shoots
and
like
come
this?
right back down. Alright.
Finals week going on.
All I want to know is, given the initial velocity of the bullet, 101 meters per second is the initial velocity right out of the chamber. I want to know the maximum height. Alright, so before work ahead of me, even though you haven't seen one of these worked, I think you know enough from free fall and from cars accelerating down the road to work this. So let's give yourself the big 5, X, B, V sub O, A, and T. Work your way down the list until you know what equation it is that you'll use. When you have a conjecture on what equation to use, flag me down and point to the equation, write it down, and let me see if it's the correct one. And I'll give you the okay to finish. So you're working toward the equation. Adam, there's a dramatic pause here.
Pausing for a brief intermission.
Got one yet? Which equation? All right, go on with that.
That HT stands for height, right?
It does. Find height. In our equation, height shows up. In our equation, height shows up as x, a displacement. So make sure you have x in your equation. It is what we're looking for. All right. Do you know what equation? Which one? Yep. Onward. Go ahead and actually put the values in and find the maximum height. V squared, very good. Because this problem is for maximum height, we can cut the problem off